5, 4, 3, 2, and 1. Okay, so who can tell me why number 1 simplifies to 2x plus 3? David? Yeah, buddy. But actually, is this called an equation, David? Why? What's missing? Equal sign, okay? So if you put plus 2x and you were adding 2x to what's supposed to be both sides of the equation, remember there is no equal sign here. So you're just merging these together. You're basically combining like terms. 4x minus 2x, David, gives you what? 2x. And then the plus 3 does not get combined. Why does the plus 3 stay separate? It's not a like term, okay? There's no other constant. Number 2. Caitlin?
You do 8y minus 3y, and you get 5y. And then x minus 4x minus 3x, which is x. And then 7 minus 2, which is 5.
Whoops, I did that one wrong. And you said this one gave you x, and then -2 and 7 gave you 5. Very good. Any questions on that one for Miss Alonzo? Okay. You have a question, Segi?
Why is it plus 5 and not minus 5?
Caitlin, why is it plus 5 and not minus 5?
What?
Why is the last term plus 5 and not minus 5?
Because they're both not negative.
Okay.
The 7 isn't negative.
Good. And the 7 is? Positive, but also why did the positive take over?
Because it's bigger.
The 7 was the bigger number. So think of this, Segi, as 7 minus 2, right? And that would just give you positive 5.
Oh, yeah.
Okay? All right. Number 3. Why did nothing combine? Karen?
Yeah, because the first term has an exponent, the second one doesn't, and the third one is a line.
Very good. The second one actually does have an exponent. Does anyone know what the exponent of that x is?
1.
It's 1, okay? If it helps you to write that in there, write in the 1, okay? But all 3 of these are not like terms because they have different variables and exponents, okay?
And the bases.
The bases are the same, though, because they're both x, right? But their exponents were different, okay? All right, so what we're learning today is we're going to learn something about something called a polynomial, okay? A polynomial just means that you have more than one term, okay? So the first thing we're going to talk about is something called a monomial, which is where you have exactly one term. Write that down. So a monomial, by definition, is a number, a variable, or the product of a number and one or more variables with whole number exponents, okay? The degree of a monomial is the sum of the exponents of the variables. Guys, circle variables. You only care about the exponents of the variables when you're calculating a degree. The degree of a non-zero constant term is always 0, and the degree of this constant 0, it does not have a degree, okay? So if you have the number 0, there's no degree there.
Why do I feel like this is going to be so hard?
It's not. It's very easy, okay? So check out the monomials on the left. If it's a constant without, what's missing from this 10? A variable, right? If it's a constant without a variable, what's its degree? 0, okay? If it has a constant, which is 3, and a variable, you care about the exponent of the variable. What's my variable in 3x? X. What's x's exponent? 1. So the degree is 1. Now, in your monomial, if there's more than one exponent, how many exponents do I have in that third one? Yes. Did I say exponents? I meant how many variables, and you guys answered me correctly. There's 2. What is the exponent of the A?
1.
What's the exponent of the B? So what do we do with those exponents? You add them together and you get 3. So the degree of this monomial is 3. Cool? That's all you have to do. And the last one. What's my variable? What's its exponent? So the degree is 5. Okay?
This is like a blessing.
Now, Segi, what's up?
So does the base not matter?
The base does not matter, but what you're looking for in the base, Segi, is you want to make sure that your base is a variable. Because if your base is a constant, do you see how we're kind of just ignoring this number in front? If it's a constant, you don't care about its its exponent, okay? All right, now take a look at some examples of not monomials. Why would that first one not be a monomial? 5 plus x. They're not together, right? They're not being multiplied. Remember, in order to be part of the same term, you have to be multiplied by each other, okay? These ones are being what? What operation is that? Addition, right? And that's going to create two separate terms, not a monomial. What about the second one? Why would that not be a monomial? It's division, right? But more specifically, the variable's in the denominator. You could have n over 2, and that would be a monomial. But 2 over n, circle the n cannot be in the denominator. What about 4 to the a? Why is that not a monomial? Yeah?
Because the variable is an exponent.
Very good. The variable is your exponent. And then x to the negative 1. You guys, what is x to the negative 1? What is that equal to? 1 over x. And I said the x cannot be where? In the denominator. So this would be a no-no, okay? So these are examples you will not see, okay? But understand that these are not monomials, okay? Monomials have to be one term. All right, so we are going to find the degree of each of these monomials one by one. So let's take a look at the first one. It is 5x to the second power. What would the degree be here? Zaggy?
2.
It's 2. How'd you get 2?
Because the exponent is 2.
The exponent is 2, but the exponent for what is 2?
X.
The x, okay? Letter B. AJ?
4.
The degree is 4. Very good. Why?
Because the x has a exponent of 1, you add them.
Very good. The x has an exponent of 1. The y has an exponent of 3. And you add them together. Does this negative 1/2 technically have an exponent?
Yeah.
What is it?
1.
Why don't we add that one?
It's not a variable.
It's not a variable. Okay? Remember, you only care about the exponents of the variables. Wiguchi? Okay. What about letter C? David, what you think?
6.
The degree is 6. Very good.
You have to put the degree in 6.
I do it for the first two. I'm just gonna write down the number from now on, okay? Because it's gonna take too long to write degree for everything. For D, good. The degree is 0. All right, guys, go ahead and try the last 4, and we'll compare at the end. Karen, what's up? Why is it 0? Well, what's the exponent of the negative 3? 1, right? But I only care about exponents of what? No, I only care about the exponents of what? Variables. Is there a variable there? No, so that's why the degree is 0, okay? The degree of any constant, any number is just going to be 0. Okay, compare your answers for the last 4. Go. You should have gotten 4, 5, 1, and 0. 4, 5, 1, and 0. Any questions on those 4? You guys talked about it? We're all on the same page. Love you guys. Okay, let's move on. So, now we are going to talk about polynomials. So before we talked about was a monomial. So we only had how many terms? 1. Okay? There was 1 term. And it's all 1 term when you're multiplying or dividing, okay, inside that term. Now, when we get to have more than 1 term, this guy, for example, has 2 terms. Why are there 2 terms here?
Binomial.
Because it's a binomial, because what are they separated by? Addition, okay? So when you have addition or subtraction, take a look at that star over on the right. Your terms are going to be separated by addition and subtraction, okay? So whenever you see a plus symbol or a minus symbol, okay, that's going to indicate that there's more than 1 term there. So now, we call polynomials with exactly 2 terms, we call them a binomial. And then terms with 3 terms, what do we call them? trinomial. So you're going to see 2 plus signs or 2 minus signs, or a combination of them, okay? Now, am I able to combine the 5x and the 2? No, because they're not like terms. So do you see how this will be a binomial regardless of how far we simplify or not? So some polynomials we cannot simplify further, okay? But other examples, and I want you to copy this one down. If we started with 3x plus 4x minus 7, initially we look at this and we're like, oh, it's a trinomial because there's 3 terms. Do you guys agree? But when we simplify, it's actually going to turn into a binomial. Why would this turn into a binomial? Caitlin. Very good. We can combine the 3x and the 4x and get what? 7x minus 7. So now how many terms do I have here? Dose. So it's a binomial, okay? All right. Now, there are some new definitions that we're going to have to be comfortable with, okay? So if anyone wants to make a Quizlet, feel free, okay? And I'll share it with the class. The degree of a polynomial. So the degree of a polynomial is the greatest degree of its terms. So whichever term has the highest degree, that's the degree of the entire polynomial. So let's look. This binomial, what is the degree of the 5x? What's the degree of the 2? Which is the higher degree, 1 or 0? 1. So what's the degree of this entire binomial? It's 1. You don't add them together. Yes? Because it doesn't have a variable. Okay? All right. What about a trinomial? Let's check out this trinomial. What's the degree of x squared? What's the degree of 5x? What's the degree of 2? Which one's the highest degree? So the degree of this entire trinomial is 2. Do you see how some cases we add them together for individual terms, but when they're separate terms, don't add them together for the degree of the polynomial? Okay? All right. Then we talk about something called standard form. Standard form is when your exponents of the terms decrease from left to right. Now watch. Look up here. The binomial. Do you see how it goes from 1 to 0? Is that from greatest to least?
Yes.
So it's in standard form. Take a look at the trinomial. 2 to 1 to 0. Greatest to least?
Yes.
So it's also in standard form. Your job is you're going to be given polynomials that are not in standard form. You have to change them into standard form. Okay? And then lastly, once it's in standard form, the coefficient. Do we remember what coefficient is? Kind of? Okay, so underneath coefficient, underline it and write a little note to yourself. If I have like 3xy, do you guys agree that's all one term? The number in front of your variables is your coefficient. So what would the coefficient be here?
3.
It would be the 3, so highlight it, okay? It's the number in front of your variables, okay, of that same term. Okay, so when you organize something into standard form, the coefficient of the very first term is called your leading coefficient, but only after it's in standard form, okay? So this guy down here, let's take a look at him. Do you guys agree this is in standard form? Why is it in standard form, McCarbin?
Because it goes from greatest to least, which is 3, 2, 1.
Very good. It goes from greatest degree to least degree. Now, look at the very first term. What's the very first term? 2x to the third. What is the coefficient of 2x to the third? 2. So that is my leading coefficient. Does that make sense? So when we do these problems, guys, you're going to notice it's not particularly difficult to get any of these answers. But what's going to be the hard part is remembering, oh, what is the leading coefficient? What is standard form? What is a binomial? What is a trinomial? There's a lot of new words here. Yeah, what's
How
up?
come 2 isn't a degree either? Or like, why isn't 2 a degree?
2 is a degree. Okay, so the degrees here would be 3, 2, 1, and 0.
There's just no variable.
They're just pointing out that the highest degree is 3, so that's why that one comes first. Okay? Yeah, AJ?
So the leading coefficient is just always the one in the front?
Always the number in front. All right, so let's check it out. What about letter A? Is this in standard form? No. So our job is to change it into standard form. How I like to do it, I like to write the degrees above my terms. What's the degree of 15x? What's the degree of x cubed? And what's the degree of 3? So clearly it's not going from greatest to least. Do you guys agree? How could I rearrange this expression so it is greatest to least? Segi?
Negative x plus 15x plus 3.
You're missing one thing.
The degrees.
Yep. What degree goes on that negative x?
3.
There should be a third degree there. Okay? Now let's write our degrees. It's 3, then 1, then 0. Am I good? I'm perfect. Okay? This is in standard form. Give it up for Segi. Okay. Now, what is the degree of the entire thing, guys? It's not 15. It's 3. How is the degree 3 here?
Because it's the greatest degree.
The greatest degree is 3. So you take that number. Sometimes it helps. Just circle this number. That's going to be the degree of your entire thing. Yeah, David.
The leading coefficient, is it the first equation? Like
No. It's after you convert it to standard form. What's the leading coefficient here?
Negative x.
Not negative x.
negative 1.
It's negative 1.
So once we use that one.
Mm-hmm. Always after it's in standard form, that's your leading coefficient.
So you only get the degree from your leading one?
Correct. After it's in standard form. Yes?
Why is negative 1?
Because what's technically in front of this x that we don't necessarily see? Isn't there a 1 there? Okay, got to remember that. All right, letter B. David, go ahead.
Yeah, 0.
What's 0? Oh, the degrees? Yes, 0 and 1.
So in standard form,
Okay.
we have negative 9z plus 4.
Very good. Negative 9z plus 4 is standard form. Excellent. What is the degree of this guy? Very good. It's 1. What is the leading coefficient?
Negative 9.
Negative 9. Too easy? Okay, try C and D on your own. Christian Fuchsa. Yes.
The last one, the negative, we count that one as -1. Why don't we count this one as -1 as well?
Well, we only counted that one as negative 1 because there was no number there, right? So we could put a 1 there. There is a number here. What is that number? It's negative 9. So that's why our leading coefficient is negative 9. Okay? Yes, Alec. No, because they have different degrees, okay? They have different degrees.
How does it go from last lesson where there's all those things changed?
Okay, so let's talk about the first one. Is this guy in standard form? No. Who can change it into standard form for me? McCarvin.
So what I did, I put it negative t to the third power
Yep.
plus t to the second minus 10t.
Do we agree with McCarvin? Yes. Very good. Okay. What's the degree of this polynomial? 3. Why?
Because it's the highest.
That's the highest degree. What's the leading coefficient here? Negative 1. How many of us got C? Raise your hands. Okay. D. What is it in standard form? Christian.
X to the third plus 2.8x.
Mm-hmm. What's the degree?
3.
3. And the leading coefficient?
1.
1. How'd we do?
Great.
No, McCarvin. All right, we're doing the exact same thing, guys, in the next part, but you have to tell me what type of polynomial, whether it's a monomial, binomial, or a trinomial, okay? Take a look at the first one. Is it in standard form? Is there any way it's not in standard form? No, because how many terms do I have? Just 1. So I'm going to just rewrite it. It's negative 3z to the 4th. What's the degree of this guy, Addison? 4, very good. Seb, what's the leading coefficient? Nope. Negative 3. It's that coefficient in front. And Mia, what's the type of polynomial? We haven't done this, so if you don't know, ask for help. Austin, what type of polynomial is this?
A monomial.
Very good. It's a monomial. Austin, do you know why it's a monomial? It only has one term. Very good. How'd we do? Are we feeling good? Okay, one more and then I'm going to set you loose. Okay? B. Should we freak out because there's more than one variable here? No, we just take it normal. Emma, can you rewrite it in standard form, please? Do we agree with Emma?
Yes.
I do. She is absolutely right. Okay, the degrees go from 2 to 1 to 0. What's the degree of the whole thing, Colin? What's my leading coefficient, Isabella?
5.
Very good. And what is the type of polynomial, AJ?
Trinomial.
Yeah, buddy. This is a trinomial. How we feeling? Okay, do C and D on your own. Let's compare in 30 seconds. All right, C, what is it in standard form, Matthew Perez?
AQ plus Q5.
No.
No, Q5 plus AQ.
Very good. Q to the 5th plus 8Q. What's the degree, Karen?
5.
What's the leading coefficient, Sophia?
1.
And what's the type of polynomial, Caden? It's a binomial. How'd we do? Yeah.
How come you don't add the terms?
How come I don't add the terms? I get 9Q to the 5th? Like that?
Yeah, can you do it?
No, because they're not like terms. Why aren't they like terms, guys? David?
Exponent.
The exponents are different, okay? Make sure you can only add terms if their variables and their exponents match. Okay, letter D. Rewrite it in standard form. Kira, go. Kira, you're so good. How'd we do? Juliana, what's the degree of this guy? What's the leading coefficient, Juliana? Anyone know what type of polynomial this is? McCarvin? Polynomial? Okay, so anything more than 3. We know monomial, binomial, trinomial, right? You just write the number of terms. How many terms does this guy have?
4.
So it's a 4 term. And then McCarvin is right, polynomial. So if it had 15 terms, what would we call it?
15
A
nominal.
15-term polynomial. Don't call it a 15-nomial. Okay. If it had 11 terms, what would we call it? An 11-term polynomial. If it has 3 terms, what do we call it? Trinomial. Okay. We do know the number of terms for the first 3. All right. Hold on. Go back. Please, cross out all of this. This is a bunch of stuff that you don't need to know, okay? But what I do need you to pay attention to is there's going to be 2 methods for adding and subtracting polynomials. Of those 2 methods, you only need to know one of them. So whichever one speaks to you, it's like calling your name. Like, hey, I love you, okay? Just grab it and be like, I'm going to fall in love with this method. Do not do both methods for every single problem. It's just going to be a headache. Only pick one and fall in love with it. The 2 methods that you're going to learn about today, what's happening? 2 examples, okay? FYI, guys, are the vertical format and the horizontal format, okay? We're going to do both of them for the first example and then just pick one and fall in love with it, okay? So what we're doing is we're finding the sum of these 2 polynomials, so we're adding them together. Please circle the addition symbol. When we're adding, these problems are very, very basic, okay? So what you want to do is you want to write the very first polynomial that you're given, which is 2x cubed minus 5x squared plus x. You write it in standard form. Is it already in standard form? Yes. Bingo. So I just copy it down. It would be 2x cubed minus 5x squared plus x. Now this is the vertical format. So we're going to grab the second one. We're also going to put it in standard form and put it where? Underneath, okay? So in standard form, this guy's not in standard form. What is this expression in standard form? X to the third
Plus 2x
plus 2x squared
minus 1.
minus 1. Now, do you see that plus symbol that we circled? You have to put a plus sign here. We are adding these two polynomials together. Now, you must make sure that all of your terms that are on top of each other are like terms. Are these two like terms? Yep. Are these two like terms? Are these two like terms? No. So guys, erase the -1. And you have to put the -1 just further away from the x so you don't add those together. Are we clear? Now, vertically add them, okay? Just like in a standard addition problem. What's 2x cubed plus x cubed? 3x to the third. Do not change your exponent to the sixth, okay? You're combining only the numerical portions, so 2 plus 1. What about negative 5x squared plus 2x squared? Negative 3x squared. Very good. And what about positive x plus nothing? Just positive x. And then -1 plus nothing? -1. This is your answer. I lost you? Okay, if I lost you in the vertical format, please pay attention to horizontal. You're probably going to fall in love with it, okay?
Wait, vertical and horizontal are the two ways you do it?
Correct. Now, they will give you the exact same answer. I don't personally care which way you do it. But for the horizontal one, guys, you're going to have to copy down the question again. So write it down again. It was 2x to the third minus 5x squared plus x plus 2x squared plus x to the third minus 1. All right, let's do the horizontal. Horizontal, okay? You're just going to start with the very first term, which is 2x to the third. What would combine with 2x to the third? What would be a like term with 2x to the third? Find it. No, not 2x to the second. X to the third. What do you get when you add those two together? 3x to the third. Write it down. Move on to your next term. What's my next term? Negative 5x squared. What would combine with negative 5x squared? What's a like term with that? 2x squared. What do I get when I add those? Negative 3x squared. Does x have a like term? No, so you just copy it down. It'll be plus x. And my last one is -1, correct? Does it have a like term? Nope, so just copy it down, -1. Did we get the same answer? Sure did. Uh-huh. So guys, technically, algebraically, we are doing these the exact same way, but we end up having two possible ways to do it. You can either do the vertical way or the horizontal. Right now, I would like you to highlight whichever way speaks to you. Personally, I love the horizontal method. I think it's much more simpler. It makes more sense. But guys, I've had students that really get really good at the vertical format, and they really like that one, okay? It's completely up to you. Now, I would like you guys, whatever you fall in love with, I would like you to apply that one to letter B, okay?
Can you please say ionic?
All right, the answer's on the board. I want you to compare with the people around you. You should have gotten 4x squared plus 5x plus 4. Go. Okay, peeps, we are almost done. Are there any questions on letter B? Yes, Karen, what's your question? Can I do it? Okay, so I do it the horizontal way, so I did 3x squared plus x squared. Guys, what's technically in front of that x squared? A 1. What's 3 plus 1? So that's why I got 4x squared, right? Then I added x, which technically has a 1 in front. What's 1 plus 4? 5. And then negative 6 plus 10 would give me 4. That's how I got my last term. Okay? All right, the last example. So go down to the next set of examples. We're going to do the first one. Okay. These are addition problems, but you have to distribute the negative before you start. Okay? So, do you guys agree I can change this into a -1? And what do I do whenever there's a number outside my parentheses? You distribute it. So distribute, multiply that -1 by all three terms, and rewrite it. So this 4n squared plus 5, does it change? No. Put a plus sign and multiply every term on the other side by -1. What do you get? 2n squared minus 2n and plus 4. And then this is a standard addition problem, and you can solve it. Yes, Caitlin. Why did I what? Why did I make it -1? Because you don't have to. Just remember that you are distributing a negative there. So you can just leave it as a negative. Just distribute that negative to everything inside. Okay? Yes?
Second one, you just change the sign.
Just change the sign of everything. Okay? And then we just add. So 4n squared plus 2n squared is going to be 6n squared. Positive 5 and positive 4 would be plus 9. And this -2n will be minus 2n. Huh? It must be in what form at the end? Standard. All right, turn these notes in and then you guys can start packing up. Is one example with subtraction.